Myself, Dr. Naresh Kumar, Associate Professor, Department of Mathematics, Institute of Aeronautical Engineering, Dundigal, Hyderabad. Today, I want to discuss a linear differential equation of second order with constant coefficient. In last videos, we have discussed widely how we can solve a linear differential equation of second order, third order, fourth order with constant coefficient. Basically, the highest order is nth order. Nth order linear differential equation with constant coefficient. So how we can find solution of a linear differential equation with constant coefficient if q is given in our question? Q is the function of x. Q is given in the right hand side of differential equation. If q is given in our question, then we can find particular integral. If q is not given in our question, then particular integral always be 0. We find only complementary function. So here we discuss a special case, case 7, in which the value of q is in standard form, that is q is equal to e to the power ax into b. E to the power ax is first function and b is second function. Both functions are in multiply. So we have already discussed in case 6, there also e to the power ax means exponential function also present there. But in case 6, b is change, and in case 7 also b change. We have discussed already when q is given, b is given trigonometrical function sin ax or cos ax. Then how we can find pi? But in this case, we discussed if b is an algebraic function, then how we can find a particular integral. So here in detail we discuss about particular integral. In case 7, here we will discuss of linear differential equation of second order with constant coefficient in standard form. Here q is the function of x. So in q there are two functions. First function is exponential function. Q is e to the power ax into b. First function is e to the power ax is exponential function. Exponential function. And here v is algebraic function. Algebraic function. Algebraic means v is some x to the power n. In q there are two functions, both are in multiply. First is function is e to the power ax, means exponential function. This is compulsory function in case 6 and case 7. Case 6 we have already discussed, but now we are discussing case 7. In this case also first function is exponential function and second function v. V is an algebraic function, that is x to the power n, where a is constant, e to the power ax. In exponential function there is a constant, maybe positive or negative, but n is always be positive constant, x to the power n. X to the power n means n is always constant. General differential equation for case 7 is given as follows. Which is the general differential equation? Here general means in standard form of a differential equation, that is known as a general differential equation. So that is d2y over dx2 multiply here by 1 and p1 is number multiply by dy dx plus p2 some also number here and y is some function. This equal to e to the power ax. This is first function. This is very compulsory here and into b. This is equation 1. P1 and P2 are constant and e to the power ax is the first function in Q in case 7 and v where v is x to the power n only. What Q is e to the power ax into v. So here a may be positive or negative. What n is always positive constant. N is always positive constant because n is the power of variable, because x to the power n is an algebraic function. So power is positive here. Now in case 7, we will discuss about standard differential equation. So here we writing here some value of q. So here same equation d2 by dx2 multiply by 1 plus p1 is some number d by dx plus p2 is number into multiply by y is some function equal to right hand side exponential function e to the power ax into multiply by some algebraic function. So in this question in right hand side in the value of q there are product of two functions. First is exponential, other is algebraic function. So how we can find a particular integral when two functions are in multiply? First is exponential and other is algebraic. So we discussed here in detail. We are discussing in detail how we can find to complete solution of given problem. So here a may be positive and negative number, but n is always positive number. In case 7, n is only positive number. We are here falsely saying that n always be positive. So in case 7, we will discuss about the method which is applied in given standard differential equation. How we can apply to find the particular integral. So last lecture we have already discussed this topic, but here we are discussing again. So differentiating of this q, this is q function. So differentiating of this q with respect to x, d means d over dx. D means d over dx here. So d over dx differentiating this function with respect to x. So here are two functions, both are in multiply. When we are differentiating, if two functions are in multiply, then we apply product formula. Product formula means d1 here, f1 into f2. So formula is f1 d of f2 and plus f2 d of f1. This formula is applied here in this question. So here first function is constant, e to the power ax is constant, differential of v plus v constant, differential of e to the power ax. So e to the power ax, differential of v plus v differential of e to the power ax. Differential of e to the power ax is a e to the power ax. This is differentiation of e to the power ax. So here a e to the power ax. So here e to the power ax is constant. Here e to the power ax is not differentiate. So this is common to left side. So here e to the power ax taking left side. Other is dv. V is function here. D means differentiating with respect to x of v. So v is differentiate here and here is v into a number. So we write here ab. So b is derivative here. B differentiate by d. So b is taking common to right hand side. So b is taking common. If we take common b in left side, then there is mistake here. So here e to the power ax, d plus a into b. So what in first result, this result and this last result, what will be happen here? So we give here conclusion, exponential function come to left side and v is function of x, that is in right hand side. What d equal to, d convert in d plus a. This is mean conclusion. D is differentiation. Is differentiation means d is derivative with respect to x. Then in putting in place of d, d plus a. This is the proved. Next result is again, we are proving two-time differentiation. D square e to the power ax into b. So here we write d square d into d. D into d two-time differential with respect to x. E to the power ax into b. So e to the power ax into b, there are two functions. Again we apply product formula here. So d is same as. So differentiating of e to the power ax is constant. Differential of b is dv plus v is constant. Differential of e to the power ax, d e की power ax. Again differentiating this, differentiating of e to the power ax into dv plus differentiating of b into d e की power ax. So here separate, there are two parts. In both parts we are apply product formula. So here e to the power ax is constant. Differentiating again dv, d of dv. This means d square v. So here is d square v and plus dv is constant. Differential of e to the power ax means a e to the power ax. And next here differential of v into d e to the power ax. So v is constant here. Differential of d e to the power ax means 2 times differential of e to the power ax plus differential of b is dv and differential of d e to the power ax. So now here e to the power ax d square v, a e to the power ax into dv plus v, 2 times differential of e to the power ax. D square of e to the power ax means a square e to the power ax. Here a is multiply with x, so a comes in multiply. We are differentiating it 2 times, then we get a square e to the power ax. So now here a square e to the power ax plus dv is constant. Differential of e to the power ax, dv is same here. So a e to the power ax. A e to the power ax dv, a e to the power ax dv. This term and this term are same. First, second and fourth term are same. So this is the twice of a e to the power ax dv plus b a square e to the power ax and e to the power ax d square v. Here we seeing that we see that e to the power ax multiply, second term is also multiply, third term is also multiply. There is no differentiation of exponential function. So exponential function taking left side because there is no differentiation, no derivative form. But v is in derivative form. Here is d square v. Here v is differentiate 2 times with respect to x. Here is v differentiate 1 time with respect to x, dv and d square v. Here is v is not differentiate. So due to this term, b is taking right hand side, not taking left hand side. Because v is differentiate 2 time and 1 time in first and second term. So b taking to right hand side. Exponential function is not differentiating in any term. So this is taking left side. Other term are d square v. V is taking outside, d square plus 2ad plus a square. So this is known as a identity. D square plus 2ad and plus a square. 2ad and plus a square. This is d plus a ka whole square. This is identity. So we are using this identity in this formula. Then we write this d square e to the power ax into v equal to e to the power ax d plus a ka whole square into v. So here the given function in Q we differentiate 2 times. What will be happen here? So here happened that e to the power ax taking left side and b second function taking to right side. What d is differentiate 2 times. So d equal to putting d plus a ka whole square. Exponential function taking left side, other function taking right side. and in place of d, we putting d plus a. This is the main conclusion here. Second differentiate, we again see this. Now, similarly, we can show that next result which is given as follows. Again, we see that d cube, 3 times differentiating of this function. So here again we get e to the power ax to left side and b is right side and d equal to d plus a whole cube. Here is d cube. So d cube in place of d cube, we putting here d plus a to the whole cube. And d to the power 4 of e to the power ax into b. So e to the power ax to the left side and putting d equal to d plus a. Here d to the power 4. So here d plus a to the power whole 4 into b. In this case, e to the power ax taking to the left side of particular integral and putting d equal to d plus a in denominator of pi. Not in numerator, only denominator be putting in place of d equal to d plus a. B taking right hand side, exponential function taking to left side, and in denominator of particular integral putting d equal to d plus a. D square equal to d plus a ka whole square. D cube equal to d plus a ka whole cube. After apply this method, we can apply last case 4 and case 5. We have already discussed case 1, case 2, case 3, case 4, case 5. Now we case 6 and we are discussing case 7. So first of all, you are doing study one by one cases. Then you can understand easily. So in case 4 and case 5, we have already discussed here. So which we have already discussed in last lectures. Problem. Now, problem 1 based on case 7. Here, I want to solve problem based case on 7. So, what is problem? Solve d2 by dx2 minus 4d by dx plus 4y equal to q. What is q here? Q is e to the power 2x into x cube. Q is here e to the power ax into b. E to the power ax is e to the power 2x. So a is here 2 and x to the power n is x cube. X to the power n is x cube. So n is here 3. Okay, here both are positive. A and n both are positive here. So how we can find complete solution of this question? This is linear differential equation of second order with constant coefficient, and in Q there are two functions. First function is exponential e to the power 2x and second function is algebraic function x cube. X cube is an algebraic function. This is the power of variable, independent variable. Some power of independent variable, that is known as a algebraic function. Some power of e in variable, then that is known as a exponential function, e to the power x, e to the power 2x. So solution, we start to solve this question step by step. So this is very interesting question and very easy question. So how we can solve this question? We are solving here step by step. So again, this is question d2 by dx2, here multiply by 1. Next term minus 4, 4 is number. So multiply by d by dx plus 4 into y is function. 4 is number here. So we are seeing here in each derivative multiply number. So we can say that this equation is known as a constant coefficient. Coefficient means multiply. Constant means number. In each term there are only number are in multiply, not variable here. Variable are not allowed here. Only numbers are allowed. So in right hand side is e to the power 2x into x cube. This equation 1 given in our question paper. Equation 1 can also be written as. So here d square minus 4d plus 4 into y is equal to this. How we can write this? This equation convert in this we have discussed in already in detail. So here This is FD, our equation in this form. This is very important form. FD, this is some function of D. D square minus 4D plus 4. This is FD. FD into by equal to Q, where Q is e to the power 2x into x cube. This is equation 3. This is equation 2. This is given in D form, FD form. So here, solution of equation 2 in two part. Solution of equation 2 we get in two part because Q is given here. First solution is complementary function and second solution is PI, particular integral. So here first we will find complementary function CF. To find complementary function CF, we have discussed in already putting Q equal to 0. When we are putting Q equal to 0, then we can find CF. In equation 2, then we get. So here we find equation number 4, D square minus 4D plus 4 into y equal to 0. This is the value of Q. We are taking here Q is 0. Q is function of e to the power 2x and into x cube. So this result putting 0. Where FD, what is FD here? FD is this one. So where FD is G square minus 4D plus 4. This is equation number 5. Now in equation 4, putting D equal to M and removing y from 4. In our 4 equation, we find out an auxiliary form. We will find an auxiliary form. So in equation 4, to find an auxiliary form, putting D equal to M and y removing from equation 4. Then this equation convert in an auxiliary form. So here putting D equal to M and removing y from 4, then we get an auxiliary form 6. 6 equation that is in M variable, that is known as an auxiliary form. So auxiliary form means M square minus 4M plus 4 equal to 0. This is equation 6. So now factorizing equation, we want here solving M square minus 4M and plus 4 equal to 0. We find out the factor of this equation. So how we can factorizing this? So factor of this here M square minus 4M plus 4 equal to 0. So M square minus 2 plus 2 M plus 4 equal to 0. So M square minus 2M and minus 2M plus 4, this equal to 0. So here M is common, M minus 2 common, M minus 2 equal to 0. So M minus 2 common and M minus 2 equal to 0. So M minus 2, both factor are same. So we can write here M minus 2 ka whole square equal to 0. Okay. Similarly, we can factorizing of this equation number 6. Other method we can also apply here. Second method we apply here. This is M square. This is A square. This is 4M is 2AB and B square is 4. So B is here 2. A is here M. So here this is A minus B ka whole square. This is formula here minus 4M. Minus 4M is 2AB. Minus 4M is 2AB. 2AB. B is here 2. So 2A into 2. This is 4A. 4A is 4M. So 4 cancel. M is A. Number 1. M is A, B is 2. So this is A minus B ka whole square. So A is M, B is 2. Here A is M and B is 2. So putting here M minus 2 ka whole square equal to 0. So there are a square means 2 times multiply. X square equal to X into X. Similarly M minus 2 ka square, M minus 2 into M minus 2. So M minus 2 into M minus 2 equal to 0. If M minus 2 equal to 0, then M is 2. And again if M minus 2 equal to 0, then again M equal to 2. So here we get factorization of equation 6 and we get two value of m because this is quadratic equation. This is 2-degree equation. So we find here two value of m. So here m equal to, here we get roots of an auxiliary form m equal to 2 and 2. Means m equal to here 2 comma 2. There are two equal roots. Value is of roots is 2. Here roots of an auxiliary form are equal. So we apply here formula for equal roots. There are four cases to find CF. Formula for CF, there are four cases. Case 1 is different roots. We have already discussed about it. Next one is equal roots. We have already discussed about it. And the imaginary roots and conjugate roots. Any quadratic equation give four types of roots. Roots are equal, roots are different, roots are imaginary, roots are conjugate. So there are four formula to finding CF. We have discussed one by one in last lectures. So here we apply here equal roots. If roots are equal, then we apply formula for CF. So complementary function is, this is formula basically. C1 plus C2 x e to the power mx. M is roots. M is the value of quadratic equation. So here m is equal to, so putting m equal to 2 here, C1 plus C2x e to the power 2x. So this is complete CF of given question. We have first result we have find here. Here finding second part of the solution, that is PI, particular integral. We use here formula for particular integral. This is basic formula which we apply here, that is basic formula to find the particular integral in each question. Same formula we apply here. So here particular integral equal to 1 upon fd. This formula is two part, numerator and denominator. 1 is in numerator and fd is denominator and q is in numerator. So 1 upon pi is equal to 1 upon fd and into q. So here 1 upon fd, q is this function, e to the power ax into b. This is equation number 9. So we have already discussed in 9, here is multiple of two function. Multiple of two function. Q is here e to the power ax and into b. Two function is multiply here. So we have already discussed, we have proved this result. If two functions are multiply, first function is exponential function, then this exponential function taking left side of pi and in multiply, and this is numerator, and b function, other second function, taking to right hand side, and in fd, fd is in denominator, numerator is 1, in fd putting d equal to d plus a. So this is the process to find particular integral of any question. Now putting value of q from 3. What is value of q in our question? That is given in equation 3. And fd from equation 5. What is value of fd? That is given in equation 5. Both value putting in equation 9. Then we get this equation next. Pi is equal to, value of fd is 1 upon d square minus 4d plus 4 e to the power 2x into x cube. This is equation 10. This is 1 upon fd. This is the value of fd. This is the value of q. Here are two functions. Both are in multiply. First is exponential. Other is algebraic function. Now we apply rule 1. Rule 1 here applying. We have discussed in case 7, if q is e to the power ax into b, q is e to the power ax into b, then e to the power ax taking to left side of pi in numerator, and b function taking to right hand side of pi in numerator, and putting d equal to d plus a in denominator in place of d of pi. Then we get following result. So which result are particular integral equal to, this is taking left side, this is taking right side. Now in place of FD this d square minus 4d plus 4. So d equal to, putting here d plus 2. Then we write here d plus 2 ka whole square minus 4 into d plus 2 plus 4. After opening this whole square, d plus 2 ka whole square. So this is formula d square plus 4 plus 4d. A plus b ka whole square, we apply here formula. So here d square plus 4 plus 4d, multiply here minus 4 minus 4d minus 8 plus 4 into x cube. This function, exponential function, is out of the integral. So this is in answer. This is goes to answer. So this is no change in this function. This is exponential function. Now here 4d is cancel. 4d is cancel here. And 4 plus 4, 8. This is cancelled by 8. Now what is remaining term? Remaining term is only d square. So we get here 1 upon d square into x cube. 1 upon d e to the power 2x. 1 upon d square means 1 upon d into 1 upon d. 1 upon d into 1 upon d x cube. Here fx equal to x cube. Function is given x cube in equation 12. But we know that 1 upon d. What is value of 1 upon d? Here is 1. 1 upon d means integration with respect to x. D means differential with respect to x. This is d over dx. 1 upon d means integral with respect to x. Okay. So here 1 upon d. Here function is 1. So integration of x dx. So now equation 11. From equation 11 we have next result here. Particular integral equal to e to the power 2x 1 upon d square into x cube. E to the power 2x 1 upon d into 1 upon dx cube. This is equation 11. Pi is equal to e to the power 2x 1 upon d square into x cube. So here 1d taking fix here 1d 1 upon d. E to the power 2x into 1 upon d. Other 1 upon d means integration with respect to x. The function is here x cube. Function is here given x cube. So integration of x cube with respect to x. So integration with respect to x cube dx. 1 upon d x cube. This means integration x cube dx. So the answer is x to the power 4 by 4. Here not adding constant. Not adding constant here. Not adding constant because this is pi. Okay. X 4 by 4 here. Again integrating with respect to x, then we get. Now function is x to the power 4 by 4. So again integrating here 1 upon d x to the power 4 by 4 means integration x to the power 4 by 4 dx. So this is x to the power 5 by 5 into 4. So x to the power 5 upon 20. So here again 1 upon d square x cube e to the power 2x. Again integrating this. Then we get here x to the power integration x to the power 4 by 4. So x to the power 4. Here integration of x to the power 4 dx. This is x to the power 5 by 5. So now here I am writing here, we know that integration of x to the power 4 dx, that is x to the power 5 by 5. So this value I am writing here. So 1 upon 4 is constant. We are taking common here out of integral. So 1 upon 4 x to the power 5 upon 5. So final answer is e to the power 2x x to the power 5 upon 5 4 ja 20. So this is equation 12. Not adding here constant. Okay. So equation 12 is complete PI. Equation 12 is complete PI of given question. Now complete solution of 1 is y is equal to CF plus PI. This formula we apply here. Our solution is in two parts. First part is complementary function, other part is particular integral. So first we have find complementary function, that is in equation 8, and particular integral, that is in equation 12. So now adding equation 8 and 12, then we get complete solution of 1. So here y is equal to, this is complementary function, c1 plus c2x e to the power 2x plus e to the power 2x into x to the power 5 upon 20. This is equation 13. Equation 13 is complete solution of 1. So this is problem. We have solved here complete problem 1 based on case 7. So this is very important problem. This is very easy problem. This is very interesting method. How we can find complementary function and particular integral if q is given exponential function into algebraic function. Both functions are in multiply. So next problem, problem base 2. Problem second, we want to solve in next problem, same case, same procedure we apply here. So on this topic, we are solving here two problems. Problem 2 based on case 7. So this problem is d2y over dx2 minus 3 dy dx plus 2y equal to this. This is q. Here q is 2 e to the power 4x into x square. This is exponential function. This is algebraic function. And two number is multiply in q. And in first derivative, this is second order derivative. Here multiply by one number. In each term there are number only. Here is one number, here is three number, here is two number. So in left hand side there are only numbers are in multiply of the derivative. So we can say that this differential equation is known as a differential equation with constant coefficient. What in right side is q. In q there are two functions. Both functions are in multiply. First is exponential function, second is algebraic function. So now we give here complete solution step by step. So solution start here. This is d2 by dx2 minus 3 dy dx plus 2y equal to 2 e to the power 4x into x square. This is equation 1 given in our question paper. So now equation 1 can be written as here. In last question we have also same written. This is d square. d2y over dx2, this is d square. 2 time differential here. And minus 1 time differential means d. Plus no differential here means 2. D square minus 3d plus 2 into y. Y is function. Equal to this. Here is 2. This equation 2. This equation can be written in this form. This is general form. F d y is equal to q. F d, there is some function of d. In our question is, there is some function of d. F d. What is f d here? F d is here d square minus 3d and plus 2. This is f d. Okay. Y is function here. Y is function. Some function of x. Y is fx here. And q is this function. This is standard function. In their function, there are two functions. Both are in multiply. First is exponential, other is algebraic. So this is the special case 7. Now, solution of equation 2 in two part. Because q is given here. First solution is CF and second one is PI. So now here first we will find complementary function. To find complementary function, putting q equal to 0 in equation 2, then we get equation number 4. Then we get equation number 4. So here d square minus 3d plus 2 equal to 0. Here we are taking q0. Q is e to the power 4x into x square into 2. This result making 0. So q is 0 making here. Where fd, what is fd? Fd is function of d only. This result is fd. So here d square minus 3d plus 2, this equation 5. Now in 4, putting d equal to m, we want to algebraic auxiliary equation of 4. What is the auxiliary equation of 4? Then putting d equal to m and removing y from 4. Then we get an auxiliary form of 4. How we can find auxiliary form? So in auxiliary form, putting d equal to m and by removing, and right hand side must be 0. So by removing from our equation and putting d equal to m, so we get an quadratic equation that is known as a auxiliary form. So here m square minus 3m plus 2, this equal to 0, this equation 6. Now factorizing equation 6, finding value of m. How we can factorizing this? So we know that equation 6 is a quadratic form. So quadratic form, what is general quadratic form? That is ax square plus bx plus c equal to 0. Equation 6 and 7 both are same. Equation 6 and 7. After comparing 6 and 7, a is 1, b is minus 3, c is 2. So we can solve this equation in two types. One type is factorizing, other type is we apply Sridharacharya. Then we can find answer. So there are two options here. We can apply direct formula. M equal to minus b plus minus under root b square minus 4ac upon 2a. If we apply these value in here, then we can find direct roots. Otherwise, we can factorizing this. So we are factorizing here. Here is 3. Here is 2. So 3 is 2 plus 1. 2 is 2 into 1. Both value I am putting here. So here 2 plus 1 place of 3. 2 plus 1 into m plus 2. So m square minus 2m minus m plus 2 equal to 0. Here m is common. In two term m is common. M is common, same m minus 2. Minus 1 common, m minus 2 equal to 0. M minus 2 is common. So next bracket m minus 1. So m minus 2 and m minus 1 is factor of given quadratic equation. Here we solve this. M square minus 3m plus 2 equal to 0. So m square minus 3. Here 2 plus 1 I am writing m plus 2 into 1 equal to 0. So m square multiply minus sign minus 2m minus m plus 2 into 1 equal to 0. So here m is common. In two term m is common. M minus 2 and minus 1 common. M minus 2 equal to 0. So m minus 2 is common. Both factor are same here. So here m minus 1, this equal to 0. So these two are factors after factorizing this equation. So if m minus 2 is 0, then m is 2. Again m minus 1 is 0, then m is 1. So roots of an auxiliary form is different. M equal to 1 and 2. There are two positive roots. Here m equal to m1, m1 is 2 and m equal to m2, m2 is 1. So roots are different of an auxiliary form. Here roots are different. Roots are different of an auxiliary form. Auxiliary form. So using formula for CF, if roots are different, which formula we apply here? Roots are different. So this is basic general formula for roots are different. Roots are m equal to m1 and m2. Two roots are there. So m equal to m1, m1 is 2, m equal to m2, m2 is 1. So putting the value of m1 and m2. So CF is C1 e to the power 2x plus C2 e to the power x. This is complete CF of given question. Equation H is the complete complementary function of 1. half question is solved here. First solution we have find. Now, second solution. Here finding second part of the solution, that is pi, particular integral. We use here formula of pi. So pi is equal to 1 upon fd into q. This is the basic formula. In each question we apply this formula. So 1 upon fd into q. Q is e to the power ax into b. This is 9 equation. In 9 equation, exponential function taking left side and v is taking right side and putting in fd, d equal to putting d plus a. So here fd plus a. Exponential function taking left side in multiply and second function taking right hand side in multiply, and in fd 1 upon fd, fd is in denominator, so putting in d equal to d plus a in denominator. This is the basic concept to find the particular integral. Now value of q from 3 and value of fd from 5, putting in equation 9. In this equation 9, putting the value of q and v, q and fd. So what is fd here? We have already written in 5 equation. Fd is g square minus 3d plus 2. This is fd. Fd is here d square minus 3d and plus 2. This is fd. And v, q is here e to the power 2 e to the power 4x into x square. This is q. So both value I am putting, then we get equation 10. Now again apply rule 1. In last question we apply same rule 1. So here we also apply rule 1. Because problem is same. We have discussed in case 7, if q equal to e to the power ax into b, then e to the power ax taking left side of pi in numerator and b taking in right hand side of pi in numerator and putting d equal to d plus a in denominator of pi. So remember these rules. This is very important rule. So particular integral equal to, this is pi. Pi exponential function is 2 into e to the power 4x. In our q, exponential function is 2 is number which is multiply. This is taking outside in multiply in pi. So 2 is already goes to here multiply. Exponential function e to the power 4x taking left side in multiply. And x square, this is v, this is taking right hand side in multiply. And d equal to putting here, d equal to putting d plus 4. Here d convert into d plus 4 because here e to the power 4x. Compare this e to the power ax. So a is 4 here. So d plus a. D equal to d plus a. D plus means d equal to d plus 4. A is 4 here. So here putting d plus 4 in each d in denominator of pi. So here d plus 4 ka whole square minus 3 d plus 4 plus 2 into x square. This is b. So here squaring d plus 4 ka whole square. Open this. D square plus 16 and plus 8d. A square plus b square plus 2ab. D square plus 4 ka square 16 plus twice 4d ka twice 8d. So expanding d square plus 16 plus 8d, multiply minus 3. Minus 3d minus 3 4 ja 12 plus 2. Now here 12, here plus 2 and plus 16. Plus 2 plus 16, 18. 18 minus 2 plus 6 plus 8d minus 3d. So here is 5d and d square. So we get finally d square plus 5d plus 6. This term comes in outside of pi and this is inside of pi. This is integrable and differentiable. But this is not integrable and differentiable. This is an answer. In equation 11, 6 taking common. 6 number, this 6 taking common in denominator of pi. because in this term the lowest power of d to the power 0 is the lowest power. I am telling in last question, if algebraic function is there, then we are making binomial. So we are making binomial, first term is 1. So here is 6 here. In last, this is 6 here. 6 taking common. So we get here 1. And 6 goes in denominator of this function. So we write here this 6, 1 plus d square plus 5d upon 6. So we write here 1 plus x. Okay. This term taking in numerator. So this goes to inverse. Then we write 1 minus x plus x square minus x cube and plus this. This is infinite series. So this is known as a binomial theorem. This is binomial formula we apply here. With the help of binomial, we can expand this. This taking in numerator. So this to the power minus 1. So this 1 plus this x or whole to the power this minus 1. So we apply this formula here. After apply this formula, we get this. 2e to the power 4x into 1 upon 6. 1 upon 6 is common. So 1 plus d square plus 5d upon 6. This is x. So here 1 minus 1. So here minus sign is there. Here is minus sign. Minus this 1. And here is plus. And next is this cube. What in cube? D square plus 5d ka whole cube. Whole cube here. There is x square. So this is term always 0 here. Because maximum power is d6. Minimum power is d cube. And d5 and d4. All derivatives are there. But we have seen here x to the power d to the power n x square equal to 0 if n greater than 2. This n derivative is greater than 2. So derivative here d cube of x square this 0, d cube of d4 of x square this 0, d5 of x square this 0. So these are derivatives are 0. Here d, this is 4. Here d, this is cube. So these are derivatives are 0 here. So this term and higher term, other term are neglecting. Other term up to infinity, all terms are 0 here. Only these two terms we analyze here. So now here next particular integral pi, this here is minus sign. This is minus sign. So here this result, opening this whole square. So d4 plus 25d square plus multiply ka twice 10d cube and x square here. In bracket here is x square. Now this x square multiply in bracket. Then we get here. So here every place d, dx square, d square x square, d4 x square, d square x square, d cube x square. In each place, other term is 0. We are taking only first term, second term, third term. Other all terms are 0 because there is the order of derivative more than 2. But here we know that dx square is 2x. Differential of x square. 1 time differential of x square is 2x. Means d over dx of x square is 2x. And d square x square, 2 time differential of this 2. 3 time differential of x square. This is greater than this. Order is greater than the power of variable. So this result is 0. So d4 of x square, this is also 0. d5 of x square, this is also 0. d of n and x square. d of n and x square. This is 0. Because n is greater than 2. N is the order. 2 is the power of variable. So n is greater than 2. Then derivative must be 0. So here these value putting in this equation 12. So we get here. Here is minus sign. I am putting here minus sign. This is plus sign. So now we get here So here is minus sign. I am putting here this minus sign, and next here this is also minus sign, and this next. So now here is minus, and this also minus, this is minus. So now x नहीं आया इसमें. Here is 5 to the 10x, 10 3 is 30x. Here is x, 30x. So here is minus 30x. So answer is this. Here is e to the power 4x upon 54, and here is minus 30x, and here minus 6 plus 25 and 18. So 25 18 means 18 is plus 25 plus. So this is 43. 43 minus 6. So ये 37 plus 37. So this is pi here. Okay. Now complete solution of 1 is y is equal to CF plus pi. Now adding equation 8 and equation 13, then we get equation 8 is complete CF and equation 13 is complete pi. So 13 and 8 we are adding, then we get complete solution of question 1. So here we get complete solution y equal to C1 e to the power. What is your roots? 2x. This is complete solution. Y is equal to C1 e to the power 2x and plus C2 e to the power x, because we get here CF. CF is this 2x and e to the power x. This is equation number 8. Equation number 8 is our CF. So now this is CF, and plus here 1 upon e to the power 4x upon 54, and here is minus 30x and plus 37. So now C1 e to the power 2x plus C2 e to the power x and plus e to the power 4x upon 54. Minus is taking common here. So here is 30x minus 47. So this is y. This is complete CF, complete solution of question. Okay. So similarly, we can solve similar problem, same method. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.